Welcome to Ask and Learn.
So they want us to use the tournament sort to figure out how many comparisons we would need to find the second, third, all the way up to the n minus first largest element. All right, so we already found in the previous problem that it would take, or how many it would take to get our first one. So we don't need to really talk about that. So let's just talk about like second, third, and so on. So um, remember, we're assuming that n is in the form of 2 to the k for some value of k. So let's just kind of go through some values of k and see what we get. So let's say, well, if k is equal to 1, so that actually doesn't give us anything interesting, so let's do 2. So I'm just going to list 1, 2, 3 up to 4, so we compare these elements right there for our tournament sort. That one should be 4, and then we compare those, and that gives us 4. All right. So that was just finding our largest, but now let's assume that we get rid of that, replace this with negative infinity, and we want to find our second largest. All right, well, let's see how many this would give us. Well, we really don't need to compare 3 and negative infinity. We already know that one will go up. But now we need to compare 2 and 3. So that would give us 3 up top. So this would only really be one comparison. All right, well, let's figure out what our third should be. Well, for here, remember we're going to get rid of all of the 3's. So that's negative infinity. So in this case, we don't need to compare negative infinity to negative infinity. We just know that this blue negative infinity would get to move up. So you would have that. Then we would just compare 2 and negative infinity. Well, 2 is going to win. So again, we only had one comparison there. All right, now what about when k is equal to 3? So maybe I should be writing that n would be equal to 8, and then over here, n is equal to 4. So let's just write 1 to 8 really quickly. So 1, 2, 3, 4, 5, 6, 7, 8. So doing this tournament sort, so that gives us 2, 4, 6, and 8. Then we compare these two, so that's 4 versus 8. Then we compare those two, and that gives us 8. So again, we don't care about the first largest, so we can get rid of all of those. Then we put negative infinity down here. So again, we don't need to compare 7 with negative infinity. So our first comparison is going to be here. So 6 versus 7. Well, that's going to give us 7. Then we compare 4 and 7. Well, 7 wins. So to find our second largest here, that's going to be 2 comparisons. All right. And maybe just for good measure, you might already see a pattern or what this should be. Let's go ahead and do this for negative, or for the third is what I mean. So third. So again, we put negative infinity here, but since we know negative infinity should be smaller than everything else, we don't really need to do a comparison, and this negative infinity just gets popped up. So then we do 6 versus negative infinity. So that's going to be our first comparison. So 6 moves up. Then we do 4 versus 6. That's another comparison, and then 6 wins. So that's also 2. And if you were to keep doing this for the fourth, we're going to get 2, fifth, we're going to get 2, and so on and so forth. And you might notice that for each of these comparisons here, this is just k minus 1, and then over here, this is also k minus 1. So what we're going to expect, so we expect k minus 1 comparisons to find each of the next largest. And then for the very last one, we wouldn't have to compare anything since we've already sorted everything up to that point. So this is at least the way, or the answer the book expects. So depending on if you actually agree with if this is considered not really needing to compare, you could also put k here. It won't really change it too much, and even for the next question, which this one builds off, you'll still get the same answer regardless of which one of these you use. So I just kind of wanted to bring up, if this doesn't feel right to you, you could always just make an explanation of, oh, well, the number of comparisons would be always just be equal to k as opposed to k minus 1. It just kind of depends on, do you feel okay with just doing that first step that we had right there.